Today we have many ways to measure the climate directly: thermometers, barometers, anemometers, and more. We even have one method for measuring the entire planet's temperature from orbit. And no, NASA, Earth is not suffering a fever. But how do scientists know what the climate was like 1,000 years ago, or 10,000, or even 1,000,000 years ago? They do it by what are called proxies. What's a proxy? When we look up in the sky and see geese flying south in formation, we know that winter is coming soon. Geese flying south is a proxy for the approach of winter. A proxy is a piece of information that stands in for something else. It represents something else we are interested in measuring. When the proxy changes, we know that something like temperature has changed. In climate, scientists use a number of different proxies to get an idea of climate many years ago. For instance, different species of animals, insects, and plants have a range of temperature that they will tolerate. If scientists find a cold weather insect in a layer of peat bog, they will have a rough idea that cold climate existed at that time. If the next lower level has warm climate insects, they will know that the climate had changed at some date between the two levels. Scientists also use tree rings, relative percentages of isotopes, and even layers of ice in polar glaciers. Each proxy has a different story to tell. Take Greenland ice cores, for instance. By measuring the ratio between oxygen 18 and oxygen 16 in a layer of ice, scientists can get an idea of the temperature during that year's snowfall. Scientists can also measure directly the amount of carbon dioxide trapped in the gas bubbles within the ice. And scientists can measure the amount of dust in an ice layer, which is a proxy for how dry the world was at that time. More dust means less rain. With the sulfate dust trapped in the ice, scientists can estimate when volcanoes erupted somewhere in the world. No proxy is perfect, and it's never a good idea to mix proxy measurements, because there are variables involved that sometimes make the different proxies incompatible. For instance, some proxies may be more responsive in certain parts of the temperature range than in others. It's a bit like comparing apples and wing nuts.